So imagine walking into a courtroom, facing a very real prison sentence. And instead of, I don't know, calling character witnesses or arguing about your good intentions, you just pull out a whiteboard.
Right. That is quite the image.
Yeah, you don't make some emotional appeal to the judge. Instead, you start writing out like complex network topology equations,
Yeah.
quantum level math, and international human rights law just to mathematically prove your innocence.
It's staggering, honestly. I mean, you are fundamentally changing the whole language of the defense at that point.
Exactly.
By stepping away from, subjective legal interpretation, you're really forcing the court to reckon with objective, verifiable physics.
Welcome to this custom-tailored deep dive. So, our mission today for you, the listener, is to unpack an incredibly fascinating stack of sources surrounding the case of Dr. Chen-Jing Yuan, who is an independent physics scholar.
A very brilliant one, based on these texts.
Right. And the materials you've shared with us include deep legal analyses based on international human rights law, specifically the ICESCR, as well as this highly technical mathematical document analyzing Dr. Chen's own jailhouse defense and blood petition.
Yeah, and I have to say, these documents are dense. I mean, they bridge this massive gap between traditional jurisprudence and, well, statistical mechanics, which is definitely not something you see in a typical legal brief.
Not at all. Now, before we jump into the actual mechanics of this, I need to make a quick but very important note to you, the listener.
Okay, the disclaimer.
Yeah, because these sources involve politically charged legal cases within China, involving both state actions and political commentary. We want to explicitly state that we are not taking any sides here.
Absolutely.
Our mission today is purely to impartially report and just unpack the fascinating legal and scientific ideas contained in the original source material. We're simply looking at the mechanics of the arguments provided to us.
Yeah, we're basically just here to examine the intersection of law and science exactly as it's presented in the text, nothing more.
Right. And the hook here, like the core narrative we're exploring, is how this physicist deconstructed a criminal charge of picking quarrels and provoking trouble over retweets on social media using like high-level computer science and physics.
It's just wild.
It is. But before we get to the hard science and the math, we really need to establish the legal baseline. We have to understand what was actually at stake for Dr. Chen.
Right, so according to the legal analysis in the sources, Dr. Chen was actually sentenced to 1 year and 8 months in prison.
Wow.
Yeah. And the state's claim was that by retweeting articles, political satire, and various academic viewpoints, his actions caused a severe disorder of public order.
Severe disorder just from retweeting.
Exactly. The charge of picking quarrels and provoking trouble is quite broad, and in this instance, it was applied directly to his digital footprint.
A year and 8 months for retweeting. I mean, that is a really heavy consequence. So the sources initially analyzed this through the lens of the International Covenant on Economic, Social, and Cultural Rights, or the ICESCR.
Right, so the ICSCR is a core international human rights treaty, and the analysis in our sources specifically focuses on Article 15.
Which covers what, exactly?
It outlines the right of everyone to take part in cultural life and to enjoy the benefits of scientific progress and its applications.
Okay.
So the argument presented there is that punishing someone criminally for sharing academic views or political satire is highly disproportionate. They argue it violates a state's fundamental obligation to foster an open environment.
Okay, let's unpack this for a second because I want to push back a little on behalf of the listener.
Sure.
Wait, how does retweeting a political cartoon or some opinion piece count as, scientific progress or participating in cultural life?
It sounds a bit grand, doesn't it?
Yeah. It seems like a very broad interpretation of those terms. Like, if I retweet a meme, am I advancing science?
Well, it does sound like a stretch until we look at the specific context of Dr. Chen's profession. The sources address this by connecting Article 15 to Articles 6 and 7 of the exact same covenant.
And those are about work, right?
Exactly. Those articles cover the right to work. For Dr. Chen, since he is an independent scholar, interacting with information, actively seeking, receiving, and sharing diverse ideas, that is the fundamental nature of his labor.
Oh, I see.
Yeah, cultural participation isn't just about, attending a symphony or going to an art gallery. It's the active exchange of ideas.
So by cutting off his ability to share and receive ideas, they aren't just restricting his speech. They're effectively stripping him of his ability to literally do his job.
That is the core of the human rights argument, yeah.
Uh,
And the broader consequence of this, which the sources highlight, is the creation of a severe chilling effect.
right, self-censorship.
Exactly. But it's not just one person deleting a tweet. The mechanism of a chilling effect is systemic.
It spreads.
Yes, because if scholars observe that interacting with or sharing diverse, perhaps non-mainstream ideas carries a tangible risk of criminal prosecution, the entire academic community begins to internalize that boundary.
They just stop exploring complex issues altogether.
Right. The open environment required for genuine scientific and cultural development simply shuts down, all because the perceived risk outweighs the intellectual reward.
So under that framework, treating intellectual exploration as a crime is a disproportionate response that damages the whole society.
Precisely.
But here is where it gets really interesting. A human rights defense is compelling, sure, but it still relies on legal interpretation. The sources show that Dr. Chen didn't stop there.
And not at all.
No. He took his defense to an entirely different level by using computer science to deconstruct the very concept of public disorder.
He essentially puts the concept of order on trial.
Yeah, because the authorities claimed his retweets caused severe disorder. So to counter this, Dr. Chen introduces something called the Chi-App theorem.
Which is brilliant. I mean, applying distributed systems theory to human society is just an incredible analytical leap.
Right.
The CAP theorem was formulated by computer scientist Eric Brewer, and it basically states that in any distributed system, which by the way includes massive communication networks like Twitter or WeChat, you mathematically cannot guarantee 3 specific properties simultaneously.
You're forced to pick 2.
You are forced to pick 2.
Okay, let's really break those 3 properties down so we understand the physical limits of these networks.
Okay, so the 3 properties are consistency, availability, and partition tolerance.
CAP.
Right. Consistency means every single node in the network sees the exact same data at the exact same time. So if someone posts a message, every user globally sees it instantly.
Okay, makes sense. And availability.
Availability means the system is always responsive. Every request gets a non-error response, even if it's not the most recent data.
Got it. And the last one, partition tolerance.
Partition tolerance means the system continues to operate even if the communication lines between some of the nodes drop or experience massive delays.
And the theorem proves that you just can't have all 3 perfectly.
Mathematically impossible.
So when building a massive social network, what do the engineers actually choose?
Well, social networks inherently have to be partition tolerant, right? Because global internet connections will always have drops. Undersea cables get damaged, local cell towers get overloaded.
That's just physical reality.
Exactly. Second, they heavily prioritize availability. Think about it. A social network that constantly goes offline and freezes your screen just to perfectly sync data across the globe. It would lose all its users immediately.
People would hate it.
Right. Therefore, mathematically and structurally, the system is forced to sacrifice strict consistency.
It has to sacrifice consistency just to survive. It's kind of like trying to keep a massive family group chat perfectly organized.
That's a great way to look at it.
Like, if you have 50 relatives typing at once from different time zones with different internet speeds, it's physically impossible for everyone's phone to show the exact same sequence of events in real time.
Right. Someone always has bad Wi-Fi.
Exactly. And Susan gets a message late. Cousin Jimmy replies to a joke from an hour ago, completely out of context. Misunderstandings happen. The chat doesn't crash, but it is fundamentally messy.
That analogy perfectly illustrates the physics of the network. Because the system sacrifices consistency, disorder, or inconsistency is not an anomaly. It is an intrinsic, baked-in physical property of the platform.
It is the baseline state.
Exactly. It's the baseline state.
So the authorities are blaming Dr. Chen for a systemic messiness that is literally a mathematical requirement for the platform to exist. He's basically saying, you're blaming me for the fact that water is wet.
Exactly. The legal charge treats disorder as a criminal result caused by a specific individual. But the statistical mechanics demonstrate that in a complex distributed system, absolute unified order is just a mathematical impossibility.
I can hear the prosecution's counter-argument already, though.
Oh, for sure.
They would say, sure, the network is inherently messy, but your specific action worsened it. We aren't prosecuting the baseline messiness. We're claiming your retweets caused a severe disorder.
So how does physics disprove that?
He disproves it by looking at the actual physical shape of the network, using the theory of scale-free networks. The sources dive deep into the Barabasi-Albert model to explain this structure.
Okay, so how does the Barabasi-Albert model define the shape of something as abstract as a social network?
It defines it through a power law distribution, which is driven by a mechanism called preferential attachment.
Preferential attachment.
Right. Unlike a traditional highway system where most cities have a somewhat similar number of roads connecting to them, a scale-free network is highly unequal. Preferential attachment means that new nodes naturally prefer to connect to nodes that already have a lot of connections.
So it's the algorithmic equivalent of the rich get richer. Exactly. An algorithm naturally pushes new users to follow celebrities or major news outlets rather than, a random independent scholar.
Right. Nobody is getting a pop-up saying, follow this obscure physicist.
Exactly. And this creates a network dominated by massive hubs accounts with tens of millions of followers. And on the flip side, you have the vast, vast majority of users who are peripheral nodes or edge nodes with barely any connections.
And the sources note that Dr. Chen's account had fewer than 100 followers.
Yeah, tiny.
He had zero meaningful interaction, and his followers were mostly what they call zombie fans, inactive bots. He is the ultimate edge node.
He is as peripheral as a node can possibly be. And this brings us to the concept of network robustness, specifically using Cohen's critical threshold formula.
Okay, what does that formula tell us?
Well, physicists Reuven Cohen and Shlomo Havlin proved mathematically that scale-free networks are extraordinarily robust against random failures or activity at the edge nodes.
Meaning the structure doesn't break easily if a small node does something unexpected.
Right, because the vast majority of the network's structure, the load-bearing pillars, if you will, is held together by the massive hubs. You could randomly remove or highly activate almost all of the edge nodes, and the macro structure of the network wouldn't even flinch.
Wow.
Mathematically, the effect of an edge node on a global system approaches zero.
There is a really vivid analogy from Dr. Chen in the sources that drives this home. He argued that claiming his retweet caused a macro-level social collapse is like saying breathing out carbon dioxide causes global warming, so you should be in prison for it.
That's brilliant. It really highlights the absurdity of ignoring scale in legal causality.
Because, breathing out releases CO2, which technically contributes to atmospheric warming.
Right, technically. But the scale is so infinitesimally small that drawing a legal causal line from your single breath to the melting of the polar ice caps is a fundamental misapplication of cause and effect.
Scale definitely matters. But let's look at the actual transmission of the information. Because even if his structural power is zero, we've all seen a random nobody post a video that somehow gets 10 million views.
True.
What about the chain reaction? Could his one retweet have sparked a massive viral fire?
To address the viral fire argument, the sources unpack self-organized criticality, or SOC, and avalanche dynamics.
Avalanche dynamics. I just love how dramatic physics terms can be.
They really are. So it's often explained using the sand pile model.
Okay, picture a sand pile.
Right. Imagine you are dropping grains of sand one by one onto a pile. For a long time, the sand just piles up harmlessly. But eventually, the pile reaches a critical state. It becomes so extraordinarily steep and unstable that one single additional grain of sand can trigger a massive avalanche that collapses the whole structure.
So the authorities are implicitly arguing that society was the sand pile, and Dr. Chen's retweet was that final catastrophic grain of sand.
That is exactly the implied legal logic. But physics provides a rigorous way to test that logic using something called a branching process, specifically the Galton-Watson model.
Which measures what?
When information spreads, we look at a crucial metric, the mean offspring number, denoted as M, or sometimes R0 in epidemiology.
R0. We've all heard that term a lot in recent years.
Oh, definitely.
It basically means if I have a piece of information, how many people, on average, will I successfully pass it to, who will then pass it on themselves?
Right. If the mean offspring number M is greater than 1, the spread grows exponentially. If M is exactly 1, the system is in that critical state where a massive avalanche is mathematically possible.
But if it's less than 1?
If M is less than 1, the spread is subcritical. It will inevitably die out.
And the sources actually run a calculation based on the reality of Dr. Chen's account metrics to find his specific M value.
They do. To calculate this, you really have to look at visibility and engagement. With fewer than 100 followers, most of them inactive, and no algorithmic boosting pushing his content to new feeds, his visibility was near zero.
Barely anyone saw it.
Right. Factor in a standard low retweet rate, and the simulation places his M at a tiny 0.12, or under some models, as low as 0.05.
0.12. I mean, that is deeply below 1.
Because it is so far below 1, he is in the deep subcritical zone. The mathematics of the branching process dictate that the extinction probability of his information cascade is essentially 100%.
Wow.
The expected total spread of his retweet, meaning the total number of secondary retweets it will generate before dying out, is mathematically about 1.
Just 1.
Just 1. And the sources contrast this scientific reality with the actual judicial standard in the region.
What's the standard?
The law requires a post to have 500 retweets or 5,000 views to be considered a crime of this nature. Dr. Chen's scientifically expected scale is off by a magnitude of 500 times.
But let me step in here and play devil's advocate for a second.
Go for it.
Isn't there always a tiny, non-zero chance of a butterfly effect? Like, what if that one person who sees his retweet happens to be a massive hub and they decide to retweet it? The physics says the probability approaches 0, but it isn't absolute 0, right?
That is a very sharp distinction, and it's exactly where the physics meets the burden of proof in law. You're correct. In complex systems, the probability approaches 0. It is an infinitesimally small fraction, but it rarely hits absolute 0.
There's always that theoretical anomaly.
There is always a theoretical statistical anomaly.
You see, the authorities could say, see, it's theoretically possible, so the charge stands.
They could try, but that fundamentally violates the core tenet of criminal law. The law requires a chain of cause and effect to be proven beyond a reasonable doubt.
Oh?
Right. A near-zero probability absolutely destroys that required cause and effect chain. If the mathematical probability of your action causing the resulting disorder is 0.001%, the state cannot legally claim your action caused the result beyond a reasonable doubt.
I see. So science says it is highly improbable. The law looks at that high improbability and says, therefore, there is no legal causality.
Exactly. The defense is demanding that the prosecution provide actual evidence like hard data, algorithmic logs from the platform, proving that his specific retweet caused an avalanche.
Show me the receipts.
Right. Without that data, substituting a near-zero mathematical probability with a presumption of guilt is a profound failure of the legal standard.
Okay, let me see if I'm tracking this next logical step.
Okay.
If the math proves that a peripheral node mathematically cannot cause a system-wide avalanche, but social media does experience massive upheavals.
It definitely does.
I mean, the sand pile does collapse sometimes.
Yeah.
If the edge nodes aren't causing it and the network is only vulnerable at the hubs, is Dr. Chen turning this around and accusing the state of being the unstable hub?
He flips the script entirely, and it is just a brilliant strategic diagnosis of the system.
Walk us through how he models that.
Well, we established that scale-free networks are incredibly robust against random edge nodes, but their Achilles heel is their vulnerability to targeted attacks on the hubs.
Right, if you take out the big pillars.
If you take out or manipulate the major connecting nodes, the entire network splinters. Dr. Chen argues that the judicial and state authorities themselves act as massive institutional hubs in the societal network.
That makes perfect sense.
They possess immense structural power, vast reach, and high levels of baseline authority.
So when an edge node posts a cartoon, the massive network easily absorbs it. It's just a single grain of sand. But when a massive institutional hub acts,
When these institutional hubs abuse their power, when they manufacture disproportionate charges or severely damage public trust, they are the ones injecting explosive systemic energy into the network.
wow.
They're the ones artificially steepening the sand pile.
He's effectively saying to the court, I'm just a harmless grain of sand. You are the ones shaking the entire table.
Yes. He argues that the abuse of power by institutional hubs pushes society closer and closer to that dangerous supercritical state.
Right.
If a societal avalanche happens, it's not because of the final microscopic grain of sand dropped by a scholar. It is because the hubs made the entire system so unstable that a collapse was mathematically inevitable.
That is truly a profound way to frame a legal defense. I mean, he didn't just defend himself. He diagnosed the true vulnerability of the entire social system using statistical physics.
It's incredible.
He mapped the power dynamics of human society onto a network topology graph.
It really is a masterclass in interdisciplinary thinking.
Yeah.
He forces the legal system to confront the fact that their simplistic, linear view of cause and effect is entirely inadequate for the reality of a complex digital age.
Okay, we have covered some incredibly dense and fascinating ground today. So what does this all mean? Let's recap this journey.
Sounds good.
We started with an independent scholar facing vague, highly subjective legal charges of picking quarrels. But instead of playing the game by their subjective rules, he changed the entire board.
He brought physics to a law fight.
Yeah, He used the CIP theorem to prove that disorder is a built-in physical feature of networks, not a bug he created. He used preferential attachment and scale-free networks to prove his structural power was basically zero. And he used avalanche dynamics and his fractional R0 value to prove that the state's accusation of him causing severe disorder was, quite literally, a mathematical impossibility.
He basically built an impenetrable wall of physics around his actions.
It really makes you think the next time you hit retweet or, the next time you post a comment online, it's worth taking a second to recognize your exact place in this massive, chaotic, complex system we call the internet.
Very true.
Are you a load-bearing hub? Are you an edge node? What is the actual measurable physics of your digital footprint?
It is a humbling perspective to realize just how small our individual footprints usually are in a scale-free network. But it also leaves us with a fascinating, entirely new dilemma regarding the future.
Oh, what's that?
If statistical physics can mathematically prove a human being's innocence on a network by measuring their exact structural influence, what happens when we start applying these same laws to hold autonomous AI agents accountable for their digital footprints?
Oh, wow. If an AI creates a cascade.
Exactly. Who goes to jail when a supposedly subcritical algorithm suddenly causes a supercritical avalanche?
That is a terrifying thought.
If we can map out human blame using network topology, we are going to have to use these exact same physics to figure out how to police artificial intelligence as it becomes the new dominant hubs of our digital sandpile.
Are we trying to regulate quantum mechanics and AI with a 17th century legal hammer? Man, it brings us right back to that incredible image of the courtroom. The gavel comes down, the legal jargon flies, and there sits the physicist tapping his marker against the whiteboard, just waiting for the law to catch up to the laws of physics.
Waiting for the math to speak for itself.
Exactly. Well, thanks for joining us on this custom-tailored deep dive into the source material. We will see you next time.